All right, let's talk about something that sounds like it's straight out of a sci-fi movie, but it's actually being built in labs as we speak. We're talking about a battery that could charge in literally the blink of an eye. And yeah, it could completely change, well, everything.
You know the feeling, right? That dreaded low battery warning pops up, and suddenly you're scrambling for a charger, and then you have to just wait. Well, what if I told you that entire daily frustration might just become a thing of the past?
I mean, let's face it. Our entire world, our phones, our cars, you name it, it all runs on lithium-ion batteries. And they're great, but they've got some serious limits. They charge pretty slowly, they waste a ton of energy as heat, and they're based on chemical reactions that, aren't exactly great for the planet.
But what if we could just move beyond chemistry altogether? Well, that's exactly what a team of researchers in Australia, from CSIR, RMIT, and Melbourne University, have done. They've built a working prototype of a completely new way to store energy, the quantum battery.
Now, this is not just a slightly better battery. It's a whole new category of technology. Instead of those slow, clunky chemical reactions, it uses the absolutely bizarre, mind-bending rules of quantum physics. We're talking about stuff like entanglement and superposition, which lets tiny particles work together in perfect harmony to store and release energy in a way that's, well, it's totally new.
So, how big of a leap are we really talking about here? Let's put our current battery tech in the ring, head-to-head with this new quantum challenger, and you can see for yourself just how different it is.
Okay, just look at this. The differences are absolutely staggering. Charging time? We go from minutes or even an hour down to microseconds. Energy loss? We go from our phones getting hot in our hands, that's wasted energy, to almost zero loss thanks to something called a dark state. But here's the part that'll break your brain. Size versus speed. With our current batteries, the bigger it is, the slower it charges. It's just common sense. With quantum batteries, it's the exact opposite. The more molecules you pack in, the faster the whole thing charges. It completely flips our intuition on its head.
This number you're looking at right here, it represents something called a femtosecond. To give you some perspective, there are more femtoseconds in a single second than there are seconds in 30 times million years. That's the timescale we're talking about for charging these prototypes. It isn't just fast, it's practically instant. So how on earth is that even possible? How can anything charge that fast? Well, the secret is in the engine that drives this thing, and that engine is quantum mechanics itself.
Okay, so here's the basic idea. First, special molecules act like super sponges, soaking up energy from light particles called photons. Then the real quantum magic happens. All these molecules become linked or entangled. This means they can share all that new energy collectively, all at the same time instead of charging up one by one. And finally, to lock that charge in place, the whole system shifts into a dark state, which basically hides the energy from the outside world so it can't leak out.
The secret sauce for that incredible speed is a concept called superposition. Think about it like this. Instead of 1,000 workers filling 1,000 buckets one after another, imagine you have one super worker who can be in 1,000 places at once, filling all the buckets at the exact same instant. That's kind of what superposition lets this battery do.
And what about that dark state? Well, that's the key to its mind-blowing efficiency. It's a special quantum state that essentially disconnects the battery from its environment. This means the energy that's stored inside can't leak out as wasted heat. It's like having a perfect thermos that never ever goes cold. You get a battery with almost zero wasted energy.
Okay, the science is pretty wild, I get it. But let's get down to it. What does all this actually mean for us? Let's step outside the lab for a second and just imagine what our world would look like if it was powered by this instant, super efficient energy source.
Seriously, the applications are pretty much endless. Think about it, an electric car that recharges in the same time it takes you to fill up a gas tank. Or a national power grid that can store solar and wind energy with almost perfect efficiency. We're talking drones and satellites that could power up in a flash, smartphones that never die, and even medical implants like pacemakers that could last for decades without needing surgery for a replacement.
This right here, this says it all, doesn't it? On one side, you have our current reality, tangled wires, always hunting for an outlet. And on the other, you have the promise of this technology, a future where power is just there, whenever we need it, no strings attached.
And this leads to the ultimate endgame, true wireless power. Because these batteries charge using light, you could literally charge them with a laser beam from across the room. Or even crazier, imagine highways with lasers built right into them that charge your electric car while you drive. the whole concept of running out of battery could just vanish.
Now, it's really important to remember, this is still at the lab prototype stage. A commercial version is probably still a ways off, maybe by 2030, and there are definitely big hurdles to clear. But it still makes you wonder, right? It forces us to ask this incredible question. In a world where power is instant, wireless, and nearly limitless, what new things could we build? What new problems could we solve?